Hello, Luke. Welcome to Lesson 83. Today we'll be talking about coin problems. And it's similar to some of the other word problems that we've done in the past, but they're just a little bit more complex, but I think you'll find that they're not very hard. So let's go ahead and just do a quick kind of a short review anyway on some of the other problems that we've seen in the past. So let's take a look at this one right here. It says, find three consecutive integers such that 3 times the first is equal to the sum of the fourth integer and 4. Okay, so this is what we have seen before in the past, and we've had many different story problems that are similar to this, and then others that may be of a little bit of a different nature, but with all of them, the goal is to find the equation that's kind of written into the problem, right? So that's always been the goal. We're trying to find the equation, and once we find the equation, we can solve it and get to our answer, right? So in this case, we'd have to break it down and say, okay, find three consecutive integers such that 3 times the first. So let's take those 3 consecutive integers. Remember, we called them n plus 1, and then n plus 2. There are my 3 consecutive integers. And now I'm saying that the 3 times the first, so 3 times the first, which is an n, is equal to, there's my equal sign, equal, the sum, we're talking addition, of the fourth integer n4. So, oh, I'm sorry, this is a typo. This should be the third integer. The third integer, n4. So the third integer is n plus 2, and we are adding that with a 4. Okay? And then once we have it to this stage, we simply just, kind of simplify things here a little bit, and then we just solve it. Okay, and this is all just review. And we end up getting this n is equal to something, and that is our answer for the first integer, and then we can get our second and our third integer from that. All right, but the point I'm trying to make here is that the the story problems that we've been dealing with up to this point have really only dealt with one equation. There's just one equation hiding in the story problem, and we need to find it and then solve it. Okay? The difference today is we'll be looking at some story problems that have multiple equations in the story problem. All right? And so it makes it a little bit different to solve. We're going to have to use our substitution methods or our elimination methods or even our graphing methods to solve some of these newer story problems. So let's just go ahead and tackle one here and see how this works out. These ones are going to involve money. All right, it's just a nice, easy way to begin story problems that have multiple equations in them. All right, so when you see these coin problems, you really need to look for two things. There's going to be two equations hidden inside this story problem. The first equation is going to entail value. It may not be the first one, it may be the second one, but one of them is going to entail the value. All right, so when we think value, we should think, dollar and cent signs. We should be thinking of decimals and money. All right, value. How much were the coins worth? Maybe I'll put that. Value, worth. Okay, so there's going to be some equation that is going to be based upon the value or the worth of the money in the story problem. And then the second equation is going to deal with the count, or you might say the number of coins. All right? So the first one is dealing with the value of the coins. The second one is dealing with the number or the count of the coins. And so keep this in mind. If you can remember this, this will make these problems a little bit easier. All right? Okay. All right, so let's now read the story problem and try to make this all come together and make some sense. So Ben and John had 24 coins that are nickels and dimes in their piggy bank. All right, if the value of the coins is $2.10, how many, another typo, how many coins of each type do they have? All right, so just kind of without paying too much attention to the numbers, just kind of getting the general flavor of the problem. We just have to picture in our mind, a piggy bank, and Ben and John have a bunch of coins in that piggy bank, and those coins are all nickels and dimes. We don't have any quarters or pennies in there. They're all nickels and dimes, and they count it all up, and they find out that, oh, if we add all this money up, if we count the value of the money, it turns out to be $2.10. That's the value of all these coins that they have. All right. However, we don't, and we know there's 24 of them. So I could, keep drawing coins until I reach 24. But imagine these are 24 coins. What we don't know is how many of them are dimes and how many of them are nickels. Okay, that's the part we don't know. We know how much they're worth. We know how many there are, but we don't know how many of each there are. Okay. And that is the crux of this problem. That is what we're trying to solve. All right. So again, kind of going back to the two different kinds of equations we want to pull out of here. What would be the value or the worth equation here? So we need to think money. What were the coins worth? Well, that they tell us right over here, don't they? They say that the value of the coins is $2.02. So we have this is here, right? So is $2.10. Remember, is often means equals. So is meaning equals $2.10. Now, I'm going to do one thing here. They do this in your book too, and I think it just makes sense. We don't necessarily like working with decimals in equations. Unless you do. If you love working with decimals, then you don't have to do this step. But if you're like most of us and you don't really care to work with decimals in your equations, instead of thinking of this as $2.10, we're going to make this just into cents, right? Isn't this, equivalent to 210 cents, right? $2.10. It's 210 cents. So we're just going to write as 210. Remembering that this is in cents, it's not in dollars and cents. Okay? And then that way we're not having to worry about this decimal point. Okay. So we know that the value of the money is 210 cents. All right? Now, the left-hand side of this equation, how are we going to think of value in terms of the left-hand side? Well, this is where we need to kind of describe some variables here. So let's do that. What are we dealing with here? We're dealing with coins, and we're dealing with numbers of coins. All right, so we have the number of dimes, n sub d. Now we've done a lot of problems with these sub notations, so this should be pretty familiar to you. The number of dimes. All right, and then we've also got the number of nickels, n sub n. Okay, and if you think about it, how do you count up the value of money? Well, you could take the number of dimes and multiply that by the value of a dime, which is 10 cents, right? So if I have 4 dimes, I can multiply that by a 10, and that'll give me the value, 40 cents, okay? If I have, 5 nickels, and then I multiply that by its value, the value of a nickel is 5, well, then that would make it 25 cents, right? 5 times 5. So to find the value of coins, we simply count them all up and we can multiply them by their value. All right, so the number of dimes, we don't know how many there are. They didn't tell us that. That's why it's a variable. But I do know that if I wanted to calculate the value of the number of dimes in this problem, I would take the number of dimes and multiply it by 10, or the other way around, 10 times the number of dimes. Do you see how that would give me the value for all of the dimes, however many there are? All right. Now we're going to add to that the value of the nickels. Now again, we don't know how many nickels there are, but we do know to compute the value of the nickels, we would take 5, because a nickel's worth 5 cents, 5 times the number of nickels, n sub n. So do you see how the value, 10 times the number of dimes, plus the value of nickels, 5 times the number of nickels, should add up to the total value of all of our coins, which they told us is 210 cents. All right, so there we go. There we have our first equation. And which one is it for? It's for the value, right? This is computing value of the coins. So now we need to think about our second equation. And our second equation, like we said, has to deal with numbers or counts. So what did they tell us about the numbers of the nickels and dimes, or the counts of the nickels and dimes? All right. Well, they said Ben and John had 24 coins. All right. So they told us that the whole count, was 24. All the nickels and dimes added together. Now that's not the value, that's the number of coins there are. So that would fall under, this category. All right. So what can we say then about n sub d and n sub n? Well, we can say that the number of dimes, whatever that is, plus the number of nickels, whatever that is, has to be equal to what? What would that have to be equal to? That would have to be equal to 24, right? The number of dimes plus the number of nickels. They told us there are 24 coins altogether. So the two of them combined should give us 24. All right, very good. So now we end up having two equations that we've pulled out of the story problem. And we're going to call this a system of equations because they're all related to the same quantities, the same story problem. And we need to ask ourselves, well, now how can we find the number of nickels and the number of dimes? Well, this is where, like I said earlier, we can employ some of our tools from our tool chest for solving, or toolbox, I should say, for solving systems of equations. So we have two variables, n sub n and n sub d, and we have two equations. That's great. So therefore, we can solve this. So you can decide which one you'd rather use. You could use elimination, or you could use substitution, or you could use graphing, but that's usually the most, not the very most accurate way to do it. So we're going to use elimination or substitution here. And I think in this case, I'm feeling a little bit like elimination right now. So let's just do it with elimination. If you wanted to do substitution, feel free to do it. I'm just going to take this bottom equation and I'm going to multiply it by a -5. I'm going to get rid of the number of nickels. Okay, so I'm going to multiply this by a -5. All right, and if I do that, what is that going to give me? I'm going to have my first equation. That's not going to change. And then I have my second equation now, which is a -5 nd -5 nn is equal to, let's see, 24 times 5 is what? 120, I believe. So now we can go ahead and solve this. So we'll cancel these out. And then we have 10 and -5 is just going to be a 5. And d is equal to, and I'm sorry, this is a negative. My bad. That's a negative. That is going to be equal to what? 90, right? So we end up with 5 times the number of n sub d is equal to 90. And if we divide that out one step further, we end up with nd is equal to, how many times can 5 go into 90? 18 times. So the number of dimes is going to equal 18. Okay? Now, just like we've done before with our other substitution problems, we still have to go back and figure out the number of nickels. So we'll plug that number of dimes into the second equation, and we'll write it as 18 instead of n sub d plus n sub n equals 24, and this will tell us how many n sub n there are. So if we subtract 18 from both sides, we get n sub n is equal to 6. So we have 18 dimes and 6 nickels. All right, 24 coins altogether. And if you add those up, you'll get the value of $2.10. All right. So it's really not very complicated. It's just remembering that you need to pull out two equations from the story problem. And this will really help you to think of it in terms of, okay, what are they telling me in terms of value? And what are they telling me in terms of count, in terms of number? And try to get your two equations from there. All right, so let's try another one. I'm going to have you pause the video on this one. Try this on your own first, and then we'll do it together. All right, Ming has 4.45 in quarters and dimes. She has 8 more quarters than dimes. How many coins of each type does she have? All right, so we're looking for our two equations, but maybe before we even do that, what are our variables here? What are the unknowns Well, they told us that she has quarters and dimes, and they haven't told us how many of each. All right, so we know quarters and dimes are what we're looking for, so we're going to call it n sub q for number of quarters, and then we'll have an n sub d for the number of dimes. Okay, so let's do the value first. So the value of all of these quarters and dimes is 445. So we know that the value, whoops, is going to be 445 cents, right? All right. Now, what do they say about, well, actually, we can fill out the other side too. So the number of quarters, what would we have to do to figure its value? Well, we'd have to multiply that by 25 plus the number of dimes times 10. That'll give us our value. So there's our first equation. Now our second equation. That begins here. She has 8 more quarters than dimes. She has 8 more quarters than dimes. So we need to somehow write that into an equation. So we're going to say the number of quarters, she has 8 more of them. So she has more quarters than dimes. So you have to kind of think in your head, okay, the number of quarters is going to be larger than the number of dimes. And she has 8 more quarters than dimes. So therefore, we could say that the number of quarters is going to equal to the number of dimes plus 8. All right, now this is kind of tricky. This should be a D. This is kind of tricky, so make sure that you see how I got that. She has 8 more quarters. Now notice I didn't add the 8 to the quarters, okay? Because she has 8 more quarters than dimes. So if I'm trying to make these two quantities equal, I'm trying to make the number of quarters equal to the number of dimes, I need to add 8 to the number of dimes to make these two quantities, this left and right side of the equation, equal. If I were to add it to the quarters, well then, gosh, the quarters, they're already saying she has more quarters than dimes. And then I'm adding more to the quarters, then it's really not going to be equal to the number of dimes. Okay, so be careful with this. This is a common place to make a mistake right here. All right, read these very carefully and just make sure it's straight in your head, the concept that they're saying. Okay, 8 more quarters means you need to add 8 to the dimes to get that number equal to the quarters. All right, so be careful. Okay, so that's our second equation. So we'll write that one actually down here. So we have the number of quarters is equal to the number of dimes plus 8. Okay, and that's all they say there. Then they just say how many coins of each type does she have. So here is our system of equations. And in this case, if we're trying to solve this, I think it's pretty clear the easiest route to take would be substitution, right? Because they've already told us what n sub q is. N sub q is n sub d plus 8. So that's a really easy one to just plug into the first equation. So in the first equation, then we'll have 25 n sub q plus 10 times the n sub d, but the n sub, oh, whoops, I'm sorry. Confusing you. So in the first equation, we'll have 25 n sub q, but we know that n sub q is equal to n sub d plus 8. So we'll plug that in. Plus 10 times n sub d is equal to 445. Okay, so now we can multiply some things out, simplify some things, and just, solve as usual. So we distribute the 25 through. We have 25 n sub d plus, now 25 times 8 is going to be, what, 200 plus 10 n sub d equals 445. We can combine some like terms here. 25 n sub d plus 10 n sub d is 35 n sub d. And then we'll move the 200 over to the other side. We'll subtract it. And on the other side, we'll have 445 minus 200, which is 245. All right. Then we need to divide this out. So we'll have 35 on both sides. And n sub d is going to equal, let's see here, 245 divided by 35. What? 7 is 35 is 24. Da, da, da. 7. N sub d is equal to 7. Okay? Well, that's a terrible solution box. Okay, n sub d is equal to 7. So the number of dimes is equal to 7. Now what's the number of quarters? Well, we just have to plug this into this, right? So the number of quarters is going to equal n sub d, which we know is 7, plus 8, which is going to be 15. There you have it. So the number of quarters is 15. The number of dimes is 7. And if you look at it, and you can just kind of do a quick check, does she have 8 more quarters than dimes? Well, she has 15 quarters, and she has 7 dimes. So yeah, she has 8 more quarters than she does dimes. All right, so it's a good indication that we probably did this right. Excellent. Very good. Let's try another one. Go ahead and pause the video. Oh, and I already see a typo. Let's fix it. This should be dimes. Go ahead and pause the video, and then we'll do this together. All right, so once again, let's look at what we're saying here. Josh had $4.35 in nickels and dimes. If he had 18 more dimes than nickels, how many of each coin did he have? All right, well, so what are we dealing with? Well, we're dealing with numbers of nickels, n sub n, and we're dealing with numbers of dimes, n sub d. All right, so let's look at our value. Our value for all this money is 435 cents. And we find that value by taking our n sub n, our number of nickels, and multiplying that by 5, and then adding that to 10 times the number of dimes. There we go. There's our first equation. Now our second equation has to deal with the count, the number of coins we're looking at. And they tell us that he had 18 more dimes than nickels. So we have our number of nickels. Okay. And again, I'm trying to make that equal to the number of dimes. Okay, I'm trying to get this into some form of an equation here. And if they're telling me he had 18 more dimes than nickels, well, again, that means the number of dimes, that's where he has most of it. Most of those coins are dimes. So the number of dimes is 18 more than the nickels, and we need to take the nickels and add 18 to the nickels so that it would be equal in number to the number of dimes. All right? Hopefully, again, that makes sense. That is probably the trickiest part on all of these problems. And they're not always going to be worded this way, but when they are, that is the trickiest part of the problem. Okay? All right, so there's our second equation. We have n sub n, number of nickels, plus just 18 is equal to the number of dimes. Okay, so what should we use? Substitution, elimination to solve this system of equations? Again, we could use either. It's totally a matter of preference. I look at this though and I go, yep, I'm going to use substitution. Because again, I've got already in it's already solved for one variable right here, n sub d. So I can take that first equation and simply plug this in, or I should really say plug this in for the n sub d in the first equation. So let's go ahead and do that. So we have 5 times n sub n plus 10 times n sub d, which we know is n sub n plus 18, is equal to 435. All right, let's work this out. We have 5 n sub n. Distribute the 10 through, and we have 10 n sub n plus 180 equals 435. Now we can combine like terms, and we have 15 n sub n plus 180 equals 435. And then we can subtract the 180 from both sides. And if we do that, the 180s disappear. We have 15 n sub n is equal to 255, if I did that right. That looks right. Okay, and then we need to divide out. So we take this side, divide it by 15. as well as the other side, and we end up with n sub n is equal to, what's 255 divided by 15? Well, let's do it out here. 735, I believe. Yeah, there we go. 17. So n sub n is going to equal 17. And if the number of nickels is equal to 17, we can plug that back into the second equation for this, and we end up with plus 18 equals n sub d. And 17 plus 18 is 35, so the number of dimes is equal to 35. So there we go. We have 35 dimes and 17 nickels. Again, we were supposed to end up with more dimes than nickels, and we do have more dimes than nickels. Excellent. All right, let's try one more here and see how you do. All right, so it says Mary has 2 more dimes than quarters. So we get some quarters in on this one. If she has $2.65 altogether, how many of each coin does she have? Well, go ahead and pause the video, try it yourself, and then we'll do it together. All right, so if we kind of start the same way we've been starting all along, we've been working with the value first. So the value of the coins in this equation, or in this story problem, is $2.65. So we will say it's 265 cents. And what are we dealing with? We're dealing with the number of dimes and the number of quarters. So 10 times the number of dimes plus 25 times the number of quarters should give us the value, 265. All right. Now our second equation, the count. How many of each? Well, let's see, or how many in all even. Mary has 2 more dimes than quarters. So again, it's one of those more than, less than kind of problems here. So we're going to just say, okay, we have our number of dimes, and we're going to try to set this up as an equation with the number of quarters. Okay, so what do they tell us? Mary has 2 more dimes. So again, she has more dimes than she has quarters. So this number is bigger than this number right now. So in order to equate these numbers, we need to add something to the quarters. We're going to have to add 2 to the quarters so that they add up to the same number of dimes that she has, because she has 2 more dimes than quarters. Okay, so we add 2 to the quarters, and now they have the same amount on both sides of the equation sign, the equal sign. Okay, all right, so that is our second equation. So we'll write that down over here. Number of dimes is equal to number of quarters plus 2. And again, I think it just makes sense to use substitution here. It's just kind of laid out for us already. So let's take that first equation, plug in this n sub d is equal to n sub q plus 2. So we have 10 times n sub d, which is equal to n sub q plus 2, and plus 25 n sub q, which is, whoops, what am I doing? 25 n sub q. Sorry, I got distracted there. Equals 265. Okay, then let's multiply things through. So we multiply the 10 through, and we get 10 n sub q is plus 20 plus 25 n sub q is equal to 265. And we can combine our like terms, and we get 35 n sub q. And then if I subtract this 20 from both sides, right, I'm going to end up with 245 on my right side. Then I can divide both sides by 35. And so 245 divided by 35 is going to be what? I feel like we did this one before. 35, 21, 24. Yeah, 7. So we end up with n sub q is equal to 7. All right. And then if we plug that back in, we would have n sub d, and we're going to go into the second equation here. N sub d, we don't know what that is equal to n sub q. Well, now we know that that's 7 plus 2 which of course is equal to 9. So n sub d is equal to 9. Okay? 9 dimes, 7 quarters. And once more, if we kind of just make sure we did that right up here, it says 2 more dimes than quarters. So we should have more dimes than quarters. And we do. We have 9 dimes and we have 7 quarters. That's right on. So there we go. All right. Very good. I think that's probably as much as we need to go through. Hopefully after doing all of those, you feel pretty confident with these problems. It's a lot of review, really, once we get it set up. It's just, using the same old elimination or substitution that you've been using for a long time now. The hardest part is just setting these up, and it's really not bad. But do watch out for when it says more than or less than, and really slow down and think about what that means and make sure that you write it correctly. All right? Excellent. Well, we will stop here for today. Good luck on your seat work, and I will see you tomorrow.